Oh, it's you. You must have clicked on my thumbnail or my description. Glad to have you here. Why'd you click? Is it because you need to know how to tram a CNC spindle? If so, this is the video for you. I'm going to go over every step of the process on a Laguna IQ CNC. Everything I do on the Laguna IQ CNC will be totally applicable to any other CNC, with the exception of which bolts you tighten and loosen. Each CNC has a different way on holding their CNC spindle, and you'll have to figure out which bolts you tighten and loosen, and that'll be part of the process. So if that's why you're here, let's get started in talking about what we want to do. If you're still here, that means you want to learn about how to tram a CNC spindle. The following steps are needed to tram a CNC spindle appropriately. The first one is you need a flat surface, because what you're going to be doing is you're going to be adjusting the angle of this spindle so that it's perfectly perpendicular to this gantry. So the first thing you need to do is to be able to make sure that what you're measuring against down here, in this case I'm using a granite block, is perfectly parallel to this. And you do that by using shims to move this granite block up and down until it's perfectly level or parallel with this block. So that's step number one. The next thing you're going to need to do after you make sure you've got a nice flat plane here is you need to then measure the amount of angle that this spindle is out, both in the Y direction. In my case, the Y direction is long, and in the X direction. So you always measure the Y direction first, so that means you're going to put your gauges in this direction, and you're going to measure the difference between one gauge and the other. And once you've got that, then you're going to go in the X direction, that's the next step, and measure the other gauge, one against the other, and you're going to make adjustments to this spindle based on what you read. In the Y direction, what you're going to need to do is put shims either at the top of this area or down at the bottom of this area. This is where the spindle block is held to the main gantry. In the X direction, what you're going to need to do is actually move this in a tilt this way. So you're using these bolts on the IQ. This one, this one, this one, and this one. So the next step in the process, after you've adjusted your X and your Y and you're pretty sure they're lined up, is to recheck them one more time. So you'll check in the Y direction, you'll check in the X direction, because you just may have knocked the Y out of whack when you adjusted the X because you're using the same bolts. And if you find that you've done that, then you'll have to rinse and repeat, so to speak, and do the process all over again. Once you've got that perfectly aligned, the next step then will be to go ahead and surface the spoiler board. You want to do that to make sure it's perfectly flat, because for the past period of time you've been using a spindle that's been out of tram, and you want to make sure everything is nice and flat. Once you've surfaced the spoiler board, the next step would be to go ahead and surface another piece of wood. With that, let's go talk about tools. What I want to go over is the various tools we'll be using to do this process. The biggest and heaviest is this granite block. We need a nice flat surface for taking measurements off of, and so we'll be using this granite block. You could use glass or other solid surfaces that are, as long as you know they're flat. The other thing that we'll be using to make sure that this granite block is perfectly flat as compared to the gantry are some sort of shims. I'm going to be using these set of feeler gauges to make sure that this block is coplanar and perfectly level to the gantry back there. You could use other types of shims. There's all kinds of material you can use as a shim, and I won't go into all of them. You'll just need some kind of shim material, whether it's playing cards, blocks, other shims. The next thing that you're going to need that's critical is some kind of measurement device to determine how out of tram your spindle is in each direction, both the X direction and the Y direction. And we'll get into the details of that. So you need some sort of gauge device. I got this one off Amazon from Simply Stupid Tools. I'll put a link in the in the description so you can get it yourself if you want it. And it wasn't very expensive, I think right around $100, but expensive is relative. The next thing you'll need is a gauge so that you can measure each corner to determine if this block is coplanar to the gantry. In this case, what I did was I didn't have another gauge, so I used one of these gauges and I took it out of the holder and I 3D printed a holder that I could mount in my spindle. And that worked perfect. And if anybody's interested in a copy of this, I'll make it available. Just make a comment and I'll give this to you. So if you buy this same brand of Simply Stupid Tools, which is the name of it, I'm not making fun of it, then you will see how I use this in the video, and this gauge will fit right in there. The next thing you need is wrenches, a wrench to be able to adjust the nuts. You need some kind of shim material to be able to shim the CNC, in this case on my CNC, in the Y direction, so the spindle will come out or in from the gantry. So I just used aluminum foil. You could use brass, you could use anything you want, but you're gonna need some kind of shim material. And the other thing you see over here is this double-sided tape, and that was, after I got everything trimmed, I needed to test it on a piece of wood, and I used this to hold it down, but you could use clamps or anything else. Oh, you're still here. Good. That means you're still interested in learning how to tram your CNC. And if you're still interested in learning how to tram your CNC, let's go ahead and move forward and start with the physical operations of tramming this CNC. Catch you at the backside. The first step in the process of leveling out the granite brick is I'm going to take my CNC gauge and I'm going to move it to each corner of the granite brick. Now this is very heavy and you will see me struggle with trying to put shims under here, but the idea is I will shim as necessary to get everything level and flat to start with, and then I'll move into the actual tramming process. So that's what you're going to be seeing, is me trying to shim everything up. So if I look like I'm struggling a little bit, I probably am, but in the end we'll get it all shimmed out. So let's watch how we get this done. So the first thing I want to do is I'm going to put this on 0 to start out with. I'm using the Z here. That is 0.003. So I'm going to take and 0 this out now. So that's reading 0. My next step now is to come over to this corner and see what happens. This one is reading minus 0.002, which tells me that I need to come up a little bit on this side. Minus 0.002. And this one is 0, so I can keep track. So now I'm going to come forward, and this one is minus 0.003. And this corner is minus 0.003. So what this is telling me is I need to raise this end up in this corner, so it's a little bit off like this. And so I'm going to do that now. I'm going to try to get there as close as I can. So at this point, what you're watching me do is using various shims and sticking them under the granite block, and I'm using a little screwdriver to kind of help put them up. And so I did the front side there, and now I'm doing that back corner. Remember I talked about a little bit of a wobble. And now that I've got all of that done, I want to go back and recheck everything, because I've been moving the granite around and I find that I need to make a little bit more of an adjustment. And once I've got that adjustment made, you'll see me go around one more time. And the goal is for me to go around one full round without having to make any adjustments and having each corner of the block reading 0. And that's what you're seeing me get done at this time, is I've gone around and now I'm going around one more time, one last time. And if I don't have to make any adjustments and everything's 0, then we're good. And the result is, after I do this, is yep, it's 0 and we're all good and ready to move on to the next phase. So now we're at the point where we're going to 0 out these gauges and start the actual tramming process. So I know that if you loosen these nuts up too much, there's little slots in the back, they'll just fall out. So I'm not going to do that. The nuts I'm going to adjust are these nuts right here and here. So I will adjust those nuts to tram it. So the first part I will do is I'll tram it in the nod, as they say, and then I'll tram it in the X, as they say. I know that everything's flat now. Now that I know I'm working with a perfectly flat surface on this granite block, I will zero out each of the gauges, and that let me start with a zero reading on the top, and then I'll start moving down in the center, watching when the first gauge hits and then the second gauge, and then I'll have the difference between the two. Now that I'm in the center, I'll bring the spindle down deep enough so that I can get a good contact reading on one of the gauges, and then start to move it down to get a good reading on the next gauge. That reads 0.1. This one is still at 0, which is telling me that it's quite a bit off here. Okay, so this one just started reading. So this reads 0.10. As I look at this gauge for the nod, which means the back and forth on the Y direction, you can see this one is at 10 thousandths, and this one is at 30 thousandths. So that means there is a 20 thousandths difference between the two gauges, which means that I now need to tilt the spindle in this direction. So I'm going to loosen up the bolts and try to get that 20 thousandths difference out of there. And so the way I can do that is with shims between this black block and this silver block. And since I've got to tilt it in this direction, that means I'm going to place shims at the top. So I have a 20 thousandths difference that I need to move the spindle in the top direction. I'm going to loosen it up, and I'm going to be using these aluminum foil as shims. So I'm going to try to take a little bit of a pre-look and fold this up to about 20 thousandths. I started folding up the aluminum foil and taking readings every once in a while with my caliper until I got to the point where I was at 11 thousandths and decided to fold it in half. Fold this in half now. So that's right a little under 20 thousandths. We'll see how it works out if I need to add some more. So now we'll loosen the nuts. At this point, it's a matter of loosening and tightening these nuts and then putting in the shim, adjusting the shim, refolding it, unfolding it, trying to get the right distance until we're at a point where we have acceptable deviation. So I went through that process. This took me about a half hour overall, and you saw that I sped up the video quite a bit off and on. Finally got to the point where the deviation was acceptable to me, and let me show you what it looks like in the next clip. Finished going back and forth and adjusting, and now that's what the nod reads. So it's matching at 22 thousandths on both gauges. So now it's trying to get the X-axis, and we'll see how well we do there. It could cause everything else to go out of whack. Next step, X-axis. We're ready to start the process of tramming in the X direction. So the first step is to bring the gauges up to the point where they're not touching the granite and then making them 0. And then what we'll do is we'll re-lower it to where both gauges are touching, and then that will tell us the deviation because they've both been zeroed at the same time. So that's what we're doing now. Okay, the right gauge just moved. Now I want to wait for the left gauge to move. Okay, the left gauge just moved and it's got good movement. It's at 0.05 or 0.005. So now I need to get these aligned in this direction. Now we're at the point where I want to align these two in this direction, and I've got the shim knotted this way, so I need to be careful. I need to take 3 of them loose and keep one kind of snug so everything doesn't come out of kilter. And the way I need to go is I need to come up on this side so that it matches this side. So I need to tilt in this direction. So I'm going to keep this one snug and loosen up these 3. Just loosen them a little. I don't want to get them real loose. So let's see if I can move this at all. Not yet. See if I can snug that down just a little bit more. Okay, that's looking pretty close. Looks pretty darn close. They look like they're matching pretty well. Let's hope it stays that way and we didn't knock the knot out. So I've tightened everything down and we're at the point now where I want to take one last check of the Y direction, which is this direction, and you can see it's about 4 thousandths difference, not that much. And then we're going to take a look at the X direction and see what that looks like. When I look at the X direction, it's about 2 thousandths, 1.5 to 2 thousandths out, so I'm going to live with those numbers. I think they look pretty good. Hey, if you're still here after I've gotten everything trammed, and that's all you wanted to learn about was the tramming process itself, it's done. If you like what you've seen, please give me a thumbs up. If you want to see future videos as they come out, go ahead and subscribe and hit that all notifications bell, and it will let you know when I put out future videos. If you do want to stick around for just a couple more minutes and watch me surface this board and check the results of the tramming, that's what's coming up next. Yesterday, I got to the point where I got everything trammed up. I got the patches, putty put into all of my screw holes. And so now the next step is to go ahead and surface this spoiler board, see how that works, and then bring on another piece of wood to try to test to see if the tram looks good and if my tram lines went away. And that's what I'm getting ready to start right now. So the first part of this process will be for me to pencil scribe the top of this surface board, which you'll see me doing, and then I'll start the surfacing process. I've already put a surfacing program into my controller, so all I have to do is zero it on the top of the bed and hit go. In the surfacing program I have sets the depth of cut to 1 millimeter or 0.0397. I find that a nice reasonable rate to go at. I don't want to take off a lot, and we'll see how it works. So that's about the point we're at. A couple things to keep in mind was when I started the process, putting in the bigger bit, which we call the slab slayer. This is the slab slayer bit that we're using right here. It's a 2.5-inch bit, and so I had to set the speed to 13,000, not 18,000. So the recommended speed for this bit is 13,000 RPM. I've already done that on my Laguna variable frequency drive controller. That's something that I have to do manually. So if you have a Laguna IQ, make sure that you set the speed for your bit to the right level. Everything else is taken care of with the software. With that, I'm going to connect up the dust collection, and I'm going to scribe the board with some pencil marks so I can tell when it's come down nice and even. At this point, you can see the pencil marks scribed across the top so that I can tell when I've got it nice and surfaced. And we're going to go ahead and start the surfacing program. That's what you see me doing over there in the corner, is getting ready to hit go. Next, you see me reaching across and feeling if the dust collector is working. I always check that because sometimes, even though it's on, it may not be aligned properly. I've done that accidentally, so it's just a check that I do, but I do it before the bit starts rotating. And now we're getting ready to actually start the surfacing path. I will go ahead and speed up the video so you don't have to watch it step by step. What you're going to see me do here is reach over right after the first pass starts and feel it to ensure it feels like about 1 millimeter, which is what I put into the program. Well, that surfacing job turned out quite nice, actually. I can't feel any ridges. We'll find out in a minute when I surface the board. There is one disappointment that I have, and that is a lot of the nail holes, or I should say screw holes, that I puttied, the putty disappeared. It was just on the surface I hadn't done a good enough job of pushing it down into the holes. So my next attempt, I'm not going to do that right now, I'll do that outside this video, will be to refill these holes with a more liquid putty and get it down into the actual holes. I might use Bondo, I might use putty, we're going to see. But so that's the only one downside so far. Next step is to put a piece of wood on here, surface it, and see how it looks. We're at the point where we're going to go ahead and surface this board and see how it turns out. I have to admit I was intimidated for a long time. This CNC has needed trammed for over a year, maybe 2 years now, and I just kept putting it off, and I'd overcome it with sanding, and it just wasn't the right way to do things. I'm glad I finally got it done. Big difference from when I previously was surfacing boards, and you can compare this board against the pictures from earlier. Hopefully this will result in fewer comments from my people watching me do the project, and I can feel good about the work I'm turning out and what I'm showing in videos. Well, that's the video. I hope you picked up a trick or two and feel a lot more confident about tramming your CNC than you did when you started watching the video. That's the goal of my channel. If you liked what you saw, please give me a thumbs up. You know, the thumbs up. Hit the subscribe button that's down there, and that way you'll be informed of future videos as they come out. It's been good to be here with you, and look forward to meeting in this medium again.